can talk a little bit about Filecoin Virtual Machine and how it can unlock new programmable storage capabilities. So Filecoin network currently has over 280 petabytes of data. But we have all of this storage, we have all of this, but we're not actually able to make a lot of sense of it. Because right now the entire process, as we just look at the storage reads and everything, it is kind of manual. But through FVM, we are actually going to see how can we automate this entire process. We're going to see what kind of capabilities can it add if all of the storage can be programmable, if we can read that state, if we can decide things based on that state. So, can you do the next slide? So before we go into what are the use cases of FVM, I want to address a little bit about how it actually work. So first of all, we have hypervisor, the high architecture, and what this basically means is basically partitioning and allocating resources and enabling multiple runtimes through this. And this is very important and fundamental because the creators of Filecoin really put a lot of mind into it. They created this storage network that has a lot of this data, right? But they also wanted to take their time to understand how is the architecture being built for other layer 1 blockchains. How can we get inspiration from them? And more importantly, how can we create something that can allow other runtimes to work on this infrastructure as well? Which is why they created this hypervisor infrastructure that can allow you to not be limited by just some particular, not being able to migrate to other blockchain infrastructure, but you can basically run EVM runtime and other runtimes as well. Yeah, and this has also been taken, in terms of some more inspiration has been taken from Unix. In terms of the architecture, a lot of low-level syscalls being made, the isolation that we practice of different components in Unix. This is the infrastructure that is basically influencing Filecoin Virtual Machine. We also have the actor model here, which is also very important because actors, you can say, are equivalent to smart contracts that we see, and they will basically have a balance, like a fill balance. They will have a state, and then this actor model can basically allow interaction between all of these different states of other actors, as well as the state of the current latest Filecoin history. Okay, so a little bit more around how this infrastructure works. So this is based on WASM, WebAssembly. WebAssembly is basically instruction stack, you can say. It was created with the objective of replacing JavaScript, but instead it is currently now used to create a lot of performant applications. This is exactly why we are using WASM here. And if you look at the different languages, what you would want to do is basically compile everything to WASM. So you can use any language, you can create and define even your own virtual machine if you want, and then you would just want to compile it back to WASM. So this is basically the way that they're doing it. If you look at how the EVM thing is working, so here you can see that we have the EVM smart contracts which are based on Solidity. And then we have the interpreter here, which is Sputnik VM. So if you are aware of the Near blockchain, right? So we have Aurora that we use. Aurora is basically that infrastructure that allows you to write Solidity code, and that basically gets deployed on Near, which uses Rust, right? This is possible because of Sputnik VM. That is exactly what we're doing. EVM bytecode, we are getting that converted into WASM, right? So this is how we can enable different foreign actors or different foreign VMs. If today you want to create a VM, you can go ahead and do it. We can get this, deployed on FVM. Not a problem, right? This is why this is very important. And we're talking about these native actors. We already have some built-in system actors. These built-in system actors, as I already said, what actors? Actors are equivalent to smart contracts. And this built-in system actors can allow you to interact with the storage market. You can talk to the minor actors. You can talk to all of these different stakeholders or the important things that are based on the storage layer of Filecoin. That is enabled. So this is already done. This is done by the Filecoin team. And then you can define your own actors. Meaning you can define your own smart contracts to do whatever computation or whatever you want. You can even create higher level actors over this to decrease the complexity. A lot of work is open source. You can start working on it if you would like. And we already have couple of SDKs out for it, starting with Rust, because Rust is like one of like a really good language if you have to compile it to Wasm, if you are part of like the Cosmos ecosystem as well, or like obviously like Solana, Near, all of these. But we are looking at Rust as one of like the very, very efficient, very performant codes that can allow you to write that kind of code that might not be possible, might not be that amount of configuration might not be possible with your normal languages that you see with Java, JavaScript and all of these, right? Alright, so we spoke a little bit about these. I want to address IPLT native. So what is this IPLT native? We're talking about interplanetary linked data. What does this mean? Okay. So Merkle, right? So IPLT is basically that standard that has been on the Filecoin storage network. This is the data model of the Filecoin storage network. This is IPLT, right? And if you're building something to allow computation over this data, you need to be able to interact with IPLT very well. You need to have proper libraries to interact, get information about the storage metadata, get information about all of these things, right? So this is why this IPLT data is very important. If you folks are interested, you should definitely check out the data structure of IPLT. It is something completely different than what you have actually seen. It's called HAMT. It's a hash array map trie. Very interesting stuff if you folks are like into data structures. Coming to foreign addressing support. Okay, so what does this mean is basically we spoke about EVM smart contracts, right? Which means that now we have Ethereum addresses here. Okay, but doesn't Filecoin have like some different sort of a F something or T something sort of an address? How are we going to make this work? How are they going to like talk to each other, right? This is done through this delegated addressing. We basically have different sort of addresses for different things. We already have Filecoin addresses starting from F0, F1, F2, F3. And for FVM, this new delegated addressing has been introduced, which means now we have a new type of address which starts with F4, followed by the like network number. For Ethereum, it is 10. So if you see any address on the Filecoin network, which is basically F410, you can be sure it's actually an Ethereum address. That's how the like conversation is, like communication is happening. And this is then followed by your exact Ethereum address, which is base64 encoded. So you can even just do it, like play with it yourself and actually see how it works. It's pretty interesting. And again, this delegated addressing is not limited to EVM. You can do this for any other thing. So that F4 will remain the same, that 10 will be replaced with some other number for some other network. This is the logic, alright? And then we're talking about abstract accounts, supporting foreign signature schemes, basically just allowing that communication even more. Because when if you're talking about FVM, whenever you create that Ethereum address, right? Whenever you do this sort of a communication, at that point of time, account abstraction is important because we don't know if it's going to be an EOA or if it's going to be a smart contract. And that happens when the first transaction is being made. That is when we get to decide if it's going to be an EOA or if it's going to be a smart contract. Okay? This is why this account abstraction along with the signature schemes are like, that should be compatible with whatever EVM is doing or any other infrastructure for that matter. And then built-in resource metering, again, we don't have Ethereum gas accounting sort of a thing here. We have like based on Filecoin, right? Because we're storing whatever fees that we would be paid to miners for the same. And also one note, if you ever develop on FVM, then do not put like a gas limit. Because it's not like how Ethereum works, it's not like a very constant sort of a thing that, okay, it must be like in that range. It is kind of very like volatile. So if you want to like build on it, do not put a gas limit on it because the gas metering does not work like how Ethereum does. Okay, I don't think I need to talk a lot about this roadmap thing. I mean, you already know that here, that is why we're talking about it. But we, in the roadmap ahead, will be seeing a lot of more built-in actors, a lot of more SDKs being created, and yeah, protocol improvements for enhanced programmability. This even compatibility testing and all of this. So we'll be looking into our tutorials, like the workshop we'll be doing later today. On the hyperspace testnet, we'll be doing like a whole thing on Remix. So yeah, just stay tuned for that. Okay, so we move to the first half. for the use cases.
Do you have slides in this that talk about the builder grants program and all? I think it's there embedded in this.
No, it's not there.
Okay, but we talk about it.
All right. Okay. So I hope till now things are clear. If there are any questions, feel to ask me. Okay. Now we're going to talk about some use cases of this. So computation over data, blah blah blah, on-chain programmability. But why is this important? Why are we talking about it? Let's see. Okay. So we have this slide which talks about a lot of things. With DataDAOs and DataOs, primarily something very important. We have replication workers, repair workers, trusted reputation system. A lot of this actually would be like, okay, what does any of this term mean? We'll just have a look. Alright, so first of all, we're going to talk about storage provider loan markets. Let's understand what this is. So for example, if you know of Ethereum, right? We moved to now POS and we're looking at people having 32 ETH to become one of the validators, right? And you would have already seen things like Rocket Pool or something where you will putting in money, aggregating that, and then you can sort of become part of that whole process, right? But now imagine for a storage provider to become a storage provider, you actually need to put some fill as a collateral. Fill is basically the native token for Filecoin. So you need to put some collateral fill. Now you might not have that much collateral, right? So what do you do now? And this is now the start of the things that can be unlocked if we have FVM. So we can basically get that, borrow all of that from some lender. Let's say Gyan here, she has a lot of Filecoin tokens. Alright, so basically I can just borrow, I can get a loan from her, and I can become a storage provider, I can then repay the loan with some interest back to her, right? This is one thing that can be unlocked using FVM. We are also looking at automated loan repayment thing, right? So let's say Gyan and I, we get on a deal and we're okay, fine, we're going to do this. So what we're going to do is maybe Lakshmi here. She can be one of the third parties. She might be a little biased towards Gyan because she's a sister. But we need an unbiased third party, and we can create a multi-sig here. And we can automate this whole process of loan repayment, where we basically discuss the terms, we have the third party, and this whole process can be done over a smart contract. Can you next slide, please? Perpetual storage deals. So a little while back, we just looked at a little bit around the Filecoin storage deal structure, that we have all of these files that are being stored, we are a client, storage provider, blah, 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 but we have an expiration date, right? And when that date expires, you will again have to scout for storage providers, set up a deal, blah, 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 a lot of things, right? You might be thinking, but why did Filecoin do this in the first place, right? You already would have been seeing other networks who basically charge a one-time fee to store data. Why? They are so simple, right? Why are we doing something so complex as this? That is because the power of configuration should always be with the end user, and that is the mindset of how all of these things are designed. And even with the perpetual storage deals that we are looking at here, the perpetuity basically talks about smart contracts renewing the deals themselves, but with some user-defined policy. So I can define something like, hey, I want, I won't pay more than this. I want to pay for this much, period I want it to be here. I want this many instances or copies of this file. That is the user policy that I can define. But if you do it on something like a one-time thing, you might not have control over that after that, right? And also, it is very weird because the charge that they might have for that file, for you to save that today, might change over time, because obviously you can't store something in perpetuity for a one-time thing. It's not going to be a very constant sort of a thing, right? So this is why this perpetual storage deal is the use of data persistent. Okay, and then we're looking at some programmable storage tools. So one of the things I want to talk about, if you were looking at the last slide, is something known as a storage bounty. Marketplace. Instead of finding out who are these storage providers and then they pitching or they coming in and then you basically set is say that I have this data, I want to store this, this is the bounty. You are the storage provider, this is the marketplace, go ahead and claim it. And all of this is automated through smart contracts. How amazing is that, right? So you can create all of these programmable storage tools on top of FVM. And because again, what is FVM? FVM is a layer 1 blockchain. So we're talking about tokens, bridges, and L2 networks. You can create your own ERC20 token on FVM. You can have bridge tokens to other blockchains, whatever. And you can have L2 networks utilize you because you can be that ground layer for them. You can have them do a lot of storage stuff back to you. For example, and I'm just giving this example to Parth over there. Solana currently backs up its on-chain data, like all of this on-chain history is back to Filecoin. Isn't that amazing? And what does this mean? What is the implication of doing that? In the coming years, you can imagine Filecoin to be a data availability layer for any of these blockchains that are being built, right? You can basically have all of your information there and you can make sense of it. Because already Filecoin is, we have seen here, capable of storing a lot of data. So we can have that kind of an infrastructure being unlocked through Filecoin. And why are we only limiting ourselves to that blockchain mentality that, okay, some blockchain can store their on-chain their history, whatever, back to Filecoin? There are even more implications of this. Okay, so I will talk about the implications a little bit later. I thought that was the next slide, but cool. We're talking about decentralized access control. So right now, if you look at access control, right, I'm sure that people would have used Amazon Web Services and that kind of a thing. Like someone has to be admin, someone will be developer, blah, 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 right? And they have some certain access levels. But it always comes down to like having that centralized control over it. How do you even design something as a decentralized access control? So we have Medusa here, which is an on-chain access control. It's like your data is encrypted, and then basically we will be enabling that access control through FVM. The validators on Medusa don't actually need to see that data. It's encrypted, they can't see that. But they can validate, and they can basically govern this access control for that, right? So we have our data which is secure, and we are building this decentralized access control over it. So this is, I think, again, a beauty of FVM. If you can see here, Bob is requesting some access to some data that re-encrypted content to Bob's key, and then that is basically to any of the platforms. So this data that you see here, it can be any data, but it's not going to be repeated. It's going to all be encrypted, and we can maintain access control over it. We can decide who gets to see, who gets to do something with it, read, write, anything. Okay, Filecoin data availability layer, why is this important, right? So imagine currently on Filecoin network, we have 280 petabytes over that right now. And we have all of this data, right, in the world, and we don't get anything for it, right? What Filecoin enables is something known as DataDAOs, which means today, if all of us in the room, we decide we are going to be a DAO, we're going to be like a FVM DAO, we're going to do some cool stuff, right? We can collectively curate useful data. I can collect data about all of you people, right? And I think this is what happens in events, right? You would have seen it. You will give your data, they will spam you, they'll call you, they'll share this data with a lot of other people, right? But how can we together maintain control over this data? We can collect all this data basically. You are a smart contract developer, you are a founder, you are someone, blah, 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 right? We can together govern and sell this data access. So it's not going to be only the organizers of an event doing something. We together can actually earn based on this data. And this is very, very important if you're talking about medical data. If you're talking about all these DNA data and all of this is very expensive stuff. If you actually just share all this data, you can actually earn a lot of money with all of these different companies who are building in this direction. But together we can govern and sell this data access. We can have a shared treasury. Now we have a treasury, right? Imagine now I have all this data, we together decide to sell this data. Now we have some money. How about we automate the cycle again? How about based on all of this money, we get more members to join our DAO. We now have more data. We can again sell this data. And this process goes on, right? This is the beauty of DataDAO. This is something that we have not seen before, right? Yeah, I think I've covered this. Alright, so this is the Filecoin master plan. Someone asked me, right, why is Filecoin doing this? What is Filecoin doing? What is their final step? There's so many protocols, this is their final goal, blah, blah, blah. And it has already onboarded so much, and so much of humanity's most important data. The step 3 is bringing compute to this data to enable web scale applications. We talk about blockchain, talk about blockchain dilemma, we talk about why we can't today build Web 2 applications that are huge, why we can't today build applications like Spotify or Twitter or Netflix, right? It's not possible, right? Blockchains are slow, we have to take care of this, we don't have that much throughput, right? But through all of the things that we have, we might be getting close. So, large-scale compute over Filecoin data, this is what we're looking at. And this is the way the infrastructure has also been designed. It's been designed with keeping in mind so many things, the hypervisor model. And the way that we are envisioning this is to basically have sister chains, having child chains, having transferring state from one to another. Over this Filecoin, like this huge data, we have hundreds of data sets currently stored on Filecoin. We can see like OpenSea, Magic Eden, Portrait, Internet Archive, all of this information is currently on the Filecoin network. And this is what can enable basically the next wave of Web3, where we have Filecoin powering all of these different blockchains based on the compute networks. This is Swan's triangle, where we're talking about privacy, verifiability, performance. So, like, we're inside your building. So, in verifiability, we're looking at ZK proofs. Privacy, we are looking at fully homomorphic encryption. Performance, we're looking at centralized cloud. And all of this, Filecoin can be that home. It can be the home for the decentralized computation networks building on top of it. Having all this data, having all of these things, you can just build on top of it. You can create something amazing on top of it. And I spoke a little bit earlier about the implications of why are we only looking at Solana or other blockchains saving their on-chain history. This is what we should be looking at, massive scale data science. Because now we have all of this data on the network, all these open source valuable data sets. And we can apply this massive scale data science, and this doesn't have to be in a manner where it's been done by a centralized authority. It can be done through this network, powered by the data of all of us, and enable basically like machine learning, AI to do even like greater things. Right now, I think a lot of people kind of shifted their focus from Web3 to AI because they saw a lot of money there. See, this is kind of like the middle ground for both the things. So try like looking into this. And again, as I was talking about, next-gen scalability, consensus breakthroughs, I don't honestly know a lot about this slide because this is kind of very advanced stuff based on the engineers of the Filecoin team. But we are powering this to enable that next-gen scalability, to be able to handle managing all these massive, large-scale data sets, applying compute over it, creating machine learning, AI, whatever you want as an L2 on top of it. Just like look into this. Like think about what kind of a consensus mechanism they need to create to enable all of this next generation scalability. And the final slide, what we're going to talk about is basically around web scale, Web3 applications, which basically implies we will be seeing soon the Netflix, the Spotify, Twitter, everything that we're talking about. This is what can power all of that Filecoin Virtual Machine. So yeah, that's it from my end. Hope you enjoyed the talk. Thank you.